Grids, also called two-way tables or arrays, are used to model the sample space for probability experiments involving two independent actions. For example, suppose I toss two coins at once. What does the sample space look like? What are the possible outcomes and what are their theoretical probabilities? To model this experiment, I draw up a grid, a table with the possible outcomes from each part of the experiment as headings for the rows and the columns. Here, the rows represent one coin and the columns represent the second coin. Now I can easily work out the sample space. Just fill in the squares in the grid. It may help to label each coin with a different colour. That may help you to see the structure of the grid. So, what are the possible outcomes? The sample space has four outcomes in it: a head then a head then a tail then a head, and a tail then a tail. But in practice, there's no real difference between the second and third outcomes in this list. They both have one head and one tail. If I marked the coins so I could tell them apart when they landed, and I actually cared about which one was which, then I would just leave it like this, with four possible outcomes, each with a probability of 1 in 4. But in this case, I'm just tossing two coins at once, so there are really only three outcomes of interest: two heads, two tails, and a head and a tail. What are the theoretical probabilities of each of these outcomes? Well, there are four outcome cells in my grid, and only one of them has two heads. So the probability of tossing two heads is 1 in 4. There's also one cell with two tails. So the probability of tossing two tails is also 1 in 4. But there are two cells with a head and a tail in them. So the probability of tossing a head and a tail, in either order, is 2 out of 4, or 1/2. Let's try a couple of problems involving grids. Imagine that you have two sets of 5 cards, each set numbered from 1 to 5. A card is drawn at random from each set, and the numbers on the cards are added together. Draw a grid to show the sample space. What sum or sums have the highest chance of occurring? And calculate the probability that you will get a sum of exactly 7. First, draw a grid. The two sets of cards become the rows and columns of the grid. In each cell inside the grid, we're going to put the sum of the numbers on each card, because the experiment says we're going to be adding together the two numbers we get. Okay, what sum or sums have the highest chance of occurring? Well, which outcome appears most often in the grid? It's 6, which occurs 5 times. The theoretical probability of getting a sum of 6 is 5 out of 25, which is 1 in 5, or 20%. And the probability of getting a sum of 7? Well, 7 occurs 4 times, so it's 4 out of 25, which is a theoretical probability of 16%. And the two parts of the compound event don't have to be the same. Let's imagine a game where there's a spinner to tell you which of 3 directions to go, and an 8-sided die to tell you how many squares you can move in that direction. Let's try calculating the probability of moving forwards at least 5 squares, and the probability of moving either left or right an even number of squares. First, we'll have to draw a grid. Each of the actions becomes either the rows or the columns of the grid. It doesn't matter which is which. I've put the spinner on the rows and the die roll on the columns. Now, what's the probability of moving forwards at least 5 squares? Well, where are those outcomes in the grid? here. There are 4 of them out of a total of 3 times 8, or 24, so the theoretical probability of moving forwards at least 5 squares is 4 out of 24, or 1 in 6. And the probability of moving either left or right an even number of squares, those outcomes are here. 8 possible outcomes out of the total of 24, which is 1 in 3.